Welcome to 61D, the course where we teach you modern full-stack web development. My name is Aiden, and today we're going to be covering a few essential developer tools and technologies that you'll need for the rest of this course and in your career generally as a developer. We're going to start by talking about how you can interact with your computer through a command line interface, as opposed to what you're probably used to, which is graphical interfaces. We'll be covering how you can specifically use Bash, which is a shell that lets you interact with your operating system. Next, we'll talk about Git, which is a way to keep track of changes to your code and a tool that enables collaboration with many developers on a single project. Finally, we'll talk about an open standard that is frequently used for writing developer documentation called Markdown. What we're going to learn today is how to use command line interfaces, which are distinct from graphical user interfaces. Chances are most of the interfaces you've used in your life have been graphical user interfaces. Here, I just have Finder on my Mac, which is a graphical user interface for exploring files. But oftentimes you can be a little more efficient by just typing in commands into a command line. For instance, if I wanted to create a file, I can do it with a command. I can say touch myfile.txt, and it'll create that file, and we'll see it's there. And we could also create a file here, say new file, maybe new folder. We'll just create a new folder, say my folder. And then here we could list all the files, and we could see we have my folder, which we just created. We'll go into more detail later, but this is just sort of basic understanding of what is a command line, what is a graphical user interface. Today, we're going to be learning command line interfaces. There are many reasons why it makes sense to get familiar with command line interfaces, which are often abbreviated to just CLI. First off is you have efficiency. With a single interface, you can interact with some application in an infinite number of ways. There's infinite number of possible commands that you can type into your one interface. If you compare that to something like a web page, there's only so many buttons and so many actions that can reasonably be fit into that web page. If you think about something like Amazon Web Services, there's, probably hundreds or tens of thousands of possible commands and actions which you could take if you're navigating through the console, but you can always, no matter what action you're trying to take, complete that action through a command line interface. And you don't have to worry about, tabbing around and clicking and finding the exact graphical menu that you need. Which moves on to the idea that you can script command line interface actions. Let's say there's a consistent setup you need to do for your Amazon Web Service, container or process you have going. You need to, trigger a certain series of actions. If you write that down into a command line interface script, then you can run it over and over again. And it's much easier to share and repeat this script, right? You can tell somebody, hey, just run this script on your computer, and it'll perform the exact same compared to if you had to write down a complicated set of instructions, which they could perform incorrectly. Additionally, because you can write these write scripts with commands, it allows you to connect together multiple different programs and have them interact. As long as you have a command line interface for your program, you could write one script, which, for instance, starts your AWS container or instance or whatever it is, and then also starts up your local development server or sets up some test server. You can control multiple programs through the same interface as opposed to having different browser tabs or different desktop applications open. And finally, there's many instances where a server isn't connected up to a monitor or any kind of graphical interface at all. If you have a remote server in a database, typically the only way that you can interact with it is through a command line interface because there's no graphical interface or monitor or anything like that attached to that server. First command line interface that we're going to learn is called bash. Bash is basically a command line interface for working with your operating system. If you need to manipulate files, kill processes, start and stop processes, inspect things about the system, all this can be accomplished using bash. Uh, Also, just as a quick clarification, I'm actually going to be using Z Shell, which is the default on Mac. Um, Bash and Z Shell are extremely similar, so it doesn't really matter for this purpose which you're going to use because everything I talk about with Z Shell is going to apply to Bash. If you're on Windows, make sure you are running Bash and not PowerShell, which is the default on Windows. You can check what shell you're running by typing echo $0, and it'll give you the name. If it says bash or Z shell, then you're all good. Also, I'm just using the default terminal application on Mac, but you can use any terminal application you want. On Windows, I would recommend using the git bash application, which should be installed if you have set up Git. So I type in our first command, which is just to clear the terminal, and it will clear out our terminal and we can begin. First thing we'll cover is how you can navigate your device's file system, which is the bash or CLI equivalent of clicking around in something like Finder on Mac or File Explorer on Windows. So to start, we want to see where we are in the file system. We can type pwd to print our current working directory. pwd stands for current working directory. As we can see, we're in our /users/Aiden folder because Aiden is the name on my device. It'll probably be your name on your machine. In addition to seeing where we are, we can see where we can go by typing ls. ls gives us all of our different directories, which is another name for folders, which are nested within this /users/Aiden folder. For now, I'm just going to navigate to our desktop. So the command for that is cd, standing for change directory, and I can go cd desktop. And there, now we're in the desktop. And if I print working directory again, we're at users Aiden desktop, like so. And then I can ls again and see what stuff I have there. If we're trying to navigate back, all you have to do is go cd .. to go back a level, or no matter where we are. So we could go cd desktop, cd my 61D folder. I can cd tilde to go back to my root directory. You can also chain multiple directories in a row. So if I want to go directly to that 61D folder, I could go cd desktop /61D in one go, and then I'm in 61D. So now that we can navigate, we can think about making and manipulating folders and files. For this demo, we can make a folder that we'll use. So we can say make dir, mkdir, and then just the name of the folder. So we will call this folder bash demo. And then we can change directory into bash demo, like so. So make dir, mkdir, was to make a directory. The other simple thing we can do is we can make a file. So to do that, we could say touch file.txt. which is, again, what we did at the very beginning of the video. So then how can we make sure that this file was created? We can ls and see that myfile.txt was created. You may start to notice that command line arguments typically have a consistent structure. You first have the actual command that you're going to do, so make directory, followed by the necessary arguments. So if we wanted to make multiple directories, we could say folder1, and folder2, then listing them. One final common structural or common thing that you see in command line interfaces are optional arguments, also known as flags. You typically see with a little flag like so. An option that we can pass into make directory is to not only make a directory, but also make the necessary parent directories. So if I wanted to have a nested folder, I couldn't just go make dir outer/inner. It's going to give me an error because outer doesn't exist yet, but I can pass an optional flag, say outer or make dir/p outer/inner, and then it'll create the outer and inner directories. So now ls I have outer, cd into outer, and I have inner, like so. And again, that applies to pretty much all command line interfaces. You have common structure of command, or sorry, what is the actual utility? So in this case, it's git. Before it was make directory. What are the arguments? And then what are the options or flags? A couple more final things that we want to do is be able to move or rename files, or maybe even copy them. So let's say we wanted to move myfile.txt into folder1. What we can do is say mv to move and say myfile.txt, and then the location that we want to move it to. So we wanted to move it, go to folder1/myfile.txt. And then if we ls, we see it's not there, but we can see into cd to folder1 and ls and see that it was created there. If we want to rename a file, we still use the move command. So let's create a file, say touch wrong name.txt, and we want to rename it. All we need to do is use the move command again, but we can just keep it in the same directory. So we can move wrong name.txt into just calling it right name.txt. And it's not going to change its location, but it is going to change the name of the file. We might want to then delete rightname.txt if we don't need that file anymore, in which case we can use the rm command or remove. So we can rm write file, or what was it, rightname.txt, and see that we deleted it. If you want to delete a folder and delete everything within the folder, you have to specify that you want to recurse down through the folders and delete everything. And to do that, we just pass in an additional flag to say rmrf. So if we wanted to get rid of everything in folder1, remember that it has, we cd into folder1, it has this file inside of it. If we want to just get rid of everything within folder1, we can say rmrf folder1, and it'll get rid of everything. Finally, if you want to copy a file, it's the same syntax as move. You just use cp instead to copy it. And there you go. That is all you need for the very basics of file manipulation. Next, we'll cover what you might want to do if you have a long command that you want to shorten. whole point of using the terminal and CLIs generally is that it allows us to go fast and be super productive. But sometimes commands, especially if they have lots of arguments, tend to get long. Or if you have to run multiple commands in a row, you might want to be able to just set them off with a single little line, like just say, create, and then it'll run a bunch of commands to set something up. Fortunately, we can achieve something like this using what are called aliases. An alias is just basically an abbreviation which maps to some longer command. If we want to set one up, all you need to go do is cd back into your root directory, and we have to create an alias file. It's possible it will already exist, but even if you don't have one, all you need to do is go touch.zshrc or your zshellrc. If you're using bash, it'll be .bashrc. I'm using zshell, so touch.zshellrc. And then I want to open it in VS Code so that I can edit it. So I will say code.zshellrc. And it'll open once it freaking verifies. And we have this. So I've got a bunch of other random configuration in here already. Don't worry about that. You can just scroll to the bottom of your file and start editing. Also, if this code alias doesn't work for you and you're on Mac, all you need to do is do Command-Shift-P, type in shell command, install code command in path, and that should set it up for you. Something that I find I type in the terminal over and over again is the clear command. And you can imagine that even though it might only save a tiny bit of time, if I type this over and over again, it'd be nicer to have it be a little bit shorter. Or what is even nicer is to potentially have cd ... alias to something shorter so that it is quicker just to go back a level in your file system. So let's do this. Go open up again your zshellrc or bashrc, and all I'm going to do is say alias cl equals clear, like that. So then the cl command is just going to run whatever clear would do. To then use this alias inside our current zshell session, all we have to do is type source.zshellrc, like so. And now we can clear, or we can CL, like that. And there we go. If you forget what an alias is set to do, you can say which CL, and it'll say CL is aliased to clear. Also, you don't have to type our source.zshellrc every single time, because every time your terminal opens, it will get all of your aliases from that zshellrc or bashrc file. So for the rest of the video, I can just type CL instead of clear. All right, so that is a super basic introduction to bash and certain bash commands. For the rest of the video, we will still be using them, so you'll still get some more practice, but it's time to conceptually move on to Git. Git is what is called a version control system, or just version control for short. There are a few alternative version control systems, but Git is by far the most used and the industry standard which you will encounter and be most likely to be asked to use. In a nutshell, Git lets you create save states called commits of your code. That way, if you introduce a bug or generally just mess up in any way, you can revert back to an old save state. Or if you want to track your progress over time and have a consistent history of the evolution of your code over time, it's helpful to have a commit log to show all the changes that have been happening over time. Imagine you're playing a video game like Minecraft, and you have the ability to, with a single click, create a backup at any time. That way, anytime you die or lose any progress, you can just hit Control Z and be reverted back to your previous save state. That's the idea behind Git. Git also has many features which enable collaboration between many people on a code base, but we'll cover those a little bit later in the video. There are graphical tools that let you interact with Git, but the default way is, again, a command line interface, which we'll learn how to use right now. So I just have an empty folder that has nothing in it at the moment, and I'm going to create a Git repository. Repository is just a project that is getting tracked by Git. So to do that, you just say git init, init being short for initialize. And then it'll say that we have initialized an empty Git repository in this specific folder. And as you can see in my terminal, you may not have this depending on what terminal you're using, but it shows that I am being tracked by Git and I have a branch. We'll cover exactly what that means later. But now I can run git status to view the status of my repository. On branch main, no commits yet, and we have nothing to commit. So I also have this open in Visual Studio Code. So let's create a file and have Git start tracking it. I'm going to just create a text file. So we'll say myfile.txt, like so. And then we can edit this. VS Code also gives you useful indicators of the status of certain files and whether or not they're tracked by Git. So this green U shows that it's untracked and there are changes which we haven't saved or haven't committed. Now let's go ahead and make our initial commit. We can say hello Git and save it. And then if we check our Git status, we see that we have an untracked file. We've created a file, but we're not tracking it with Git yet. If we want to start tracking it, we have to commit it to our Git repository. First thing you need to do is you need to stage the changes. If you have a large number of files that you're editing, you may not want to save the changes of all those files at once. But for now, we can just select everything in our repository by saying git add period to add all of our files. Then if we hit status, we see that we haven't committed anything yet, but we have a new file, myfile.txt, which is staged and ready to be committed. In order to create that initial commit, we just have to say git commit, and then every commit needs a message associated with it. So we say .m or not .m, -m to specify our message, and we can just say initial commit, like so. And there it was created. So if we go back to VS Code, we'll see that our my file is back to the default color because there are not any unsaved changes. Now that we've created that commit, we can always revert back to that save state. So if we mess something up, let's say we accidentally delete our whole file and for whatever reason our Control Z function isn't working, all we would have to do, we say git status, you see that there's something modified. If we want to undo those modifications, it's prompting us, right? We can say git restore myfile.txt, and that'll revert it back to that save state, like so. We can create a new file, so we'll call it feature1, and maybe make some edits. So we'll say, add or just cool button as our feature. And let's say we, get a little carried away, we're coding away, and we also make a few changes to my file. Hello Git, hello world, like so. So then we might go to git add everything and check our git status and see that we have multiple files which are going to be in this one commit, or multiple changes that are going to be in this one commit. It's possible that you want to keep these changes in separate commits so that it's easier to view them in isolation, right? The changes to my file are not dependent on the changes to feature one. So you might want to be able to revert feature one without reverting my file, or vice versa. To do this, we have to be able to add individual files instead of adding all the files to the staging area. We also need to be able to unstage files. So it's prompting us, telling us what we need to do. What I'm going to do is first commit the changes to feature one, and then commit my file in a separate change. So what we can do is we can first try just git restore stage feature one.txt. And then if we check our status, we only have the changes to my file and then the changes to feature one. So then we can make a commit saying modified feature one, and only the changes to that. I should have changed this. I should have said modified my file. But anyways, only the changes to my file were committed, and the feature one changes are not committed. So I messed that up. I should have had a different commit message, but we could now create another commit, adding just an individual file, adding my feature one.txt, add feature one.txt, and then git commit actually modified feature one, like so. So then we have them on two separate commits, so we can view those changes individually. And if we want to view all of our commits that we have made, and just go git log and view. We had our initial commit. It's got timestamp, commit author, and an individual hash, which identifies the commit. And then modified feature one, and when we actually modified feature one, if I didn't mess up my commits. So far, we've used Git to create a linear sequence of commits, such as a backup from a few hours ago, a day ago, multiple days ago, and shown how you can toggle between these. However, this isn't super useful if you have a large number of people working on the same project. We need a way to make sure that people don't write over each other's work and don't interfere with each other as they're working on different features. That's where the most important feature of Git comes into play, which are branches. So far, we've just been working on what is called the default branch. It's normally called main, also has been called master in the past, but it's just the default branch where we have the most up-to-date version, or at least the accepted source of truth about what your code looks like. However, if you have multiple people that all want to work on different things, it doesn't make sense for everybody to just push changes directly to this main branch willy-nilly. Because again, people could easily overwrite each other or undo and redo something, and it's just a total mess. Git allows you to diverge from the main branch and have your own working history of changes that you work on, and then at a later date, re-merge those changes back into the main branch. At the same time, somebody else can create their own separate branch so they can work completely unimpeded by whatever you're doing on your own branch. You can imagine that if you have multiple features in development, or just multiple people working on different versions of some code, this is extremely useful. My terminal is telling me directly that I'm on the main branch, but you can always check what branch you're on by typing git branch, and you'll get a little asterisk next to what your current branch is. and then you can hit Q to exit. So let's create a new branch that diverges off of this main branch. To do that, we can say git checkout -b to specify it's a new branch, and then the name of the branch. So we will call this new feature, like so. Now, if we say git branch, we are on new feature instead of main. So let's go ahead and create a new feature. We'll say touch feature2.txt. Go just make some edits, cool drop down menu, something like so. And then we can add it and commit it. So git commit, and we'll say created feature 2, like so. So now on this new feature branch, we have this feature 2 file that we created, but we can switch back to our main branch and it won't be there. We can say git checkout and then the name of the branch. So git checkout main. Now we're back on the main branch. So git branch main, and we'll see that feature2.txt doesn't exist. Then we can swap back, git checkout new feature, and now feature2.txt does exist. Let's make a couple more changes to our new feature branch and then show how branches allow you to have multiple people or just one person work on multiple different things at the same time. Let's just add something else to feature 1. We'll say with a red border, and then we can git add, git commit. Well, let's see. What did we actually change? Feature 1. Don't mess up my commit messages again. So we'll git commit added to feature 1, like so. And now we are all good. We have, git status. We are all good. So now, right, we were working on feature 1, working on feature 2, going crazy. Somebody else joins the team, they need to get started, but we don't want them to overwrite our work on new feature. We can check out the main branch and then check out yet another branch. So check out, we'll call it new feature 2. Very creative with these namings, like so. Then new feature 2 can go ahead. Maybe in addition to that red outline, they add some puppy images, like so. And as you can see, right, feature 2 is gone because we're branching off of this main branch. Then we can add, git commit, added puppy images, like so. And we have that change. So if we were again going to git checkout main, it's no longer there. Now, once our changes on our different branches are ready to go, eventually we need to merge them back into our main branch so that we can use them. To start, we want to inspect, okay, what actually changed? We can do this by saying git diff to view the differences between our current branch and some other branch. So we'll say git diff new feature, and we can see, okay, what was deleted, what was added. This is actually, okay, this is a little bit confusing. I should really have gone the opposite way. I should git checkout new feature and then git diff main. So this would show you what changes would have to be made to the main branch to get us to the point we're at with our new feature branch. So in feature1.txt, we'd have to remove cool button and then add these various different lines, cool button with a red border. Sometimes Git is not 100% accurate at sort of condensing these things. Like these two look the same. Maybe there's a hidden space somewhere or something, but we can see the changes between these two branches. Then if we check out main and get the new feature, it's going to be reversed, right? It's going to say, hey, in order to go from our main, in order to go from the new feature branch to the main branch, we would have to delete this stuff on our new feature branch and add this line. But now we can merge new feature into main. So git merge new feature, like so. So then it updates, and now we have all of our changes in our new feature branch. Or I guess those changes earlier I was saying are because we also made changes to feature 2. So now we have feature 2 and we have our red border in feature 1 all in our main branch. So now that we're merged, all good to go, we can just go ahead and delete our new feature branch. So git branch /d to delete or -d new feature deleted, and then we have fewer branches to worry about. More importantly, now we can also merge in our other branch, our new feature 2 branch. Somebody can work on new feature and then work on new feature 2, and at a point later down the line when they're both ready, they can be merged in without having overwritten each other. So let's do that. Let's first git diff new feature 2, see what we would change. We would get rid of or okay, it's a little confusing because I'm saying what do we have to do to go from main to new feature, but if we were to swap it, right? So if we were to check out new feature 2 and then diff from main, we would get rid of puppy with a red border and add puppy images. However, when we merge it, it's going to recognize, hey, those puppy images were added from another branch, and it's going to just combine all of the changes. So let's do this. Let's git check out main and git merge new feature 2. Okay, so we have a conflict. This is because Git doesn't know exactly what changes it wants to keep. We have some changes from our current main branch. These were on new feature. And then we added these puppy images on the same line. It doesn't know what to do. So it lets us decide, hey, I'm just going to either keep both of them, or it lets you accept the current, or accept incoming, or accept both, like so. Then once we're done, we just need to add and commit changes, merged conflicting changes, like so, and then we're all good. Also, if we had been changing something to a completely different file, then it's likely there would not have been any merge conflicts. Git is only going to have merge conflicts when you edit the same lines on the same file like we did. So if we were to only edit my file on one branch and then edit feature 2 on a different branch and then merge them, then there wouldn't be any changes. there we go. We had two different people working on two different branches, and then we were able to rectify those changes, and Git made it a piece of cake. So far, we've only been using Git on our local machine. However, in all practical instances, you probably want to have your Git repository hosted somewhere so that other people can access it and make changes. The most common platform for doing this is GitHub, which, as evidenced by the fact that we've been using Git and haven't talked about GitHub so far, are in fact two different things. GitHub is a hosting platform specifically designed for hosting Git repositories. There's a few important features of GitHub that it makes sense to be able to use, and it's also important to learn how you can push your local Git repository to be hosted on GitHub and how you can interact with it. So to start, we can go ahead and create a repository. I am just going to name it Git demo. Do whatever you want, make it public. And then I will not add a README or a gitignore, anything like that. And go ahead and create it like so. And now we have a hosted repository. However, we haven't pushed our local changes up to our GitHub repository. To do that, we need to add what is called a remote origin to our local repository. Basically, we're connecting our local repository to this remotely hosted repository. So it gives us convenient instructions of what we have to do. All we need to do is say git remote add origin and then the URL of the Git repository. And then we can git push our changes up to that Git repository. So git push origin, and then the name is just name of our branch. So we're on the main branch. So there we go. So now it is up on GitHub. And if we refresh this, we have all our changes right there. And we can view all of the commits that we have been working on. Quick sidebar, if you're having any issues doing what I just showed you, which is basically connecting your GitHub account to your local machine so that you can push changes, all you need to do is go to our course website, 61d.org, content, course setup, and make sure that you have followed everything here. You should be all good if you can run GitHub auth status. So we can copy that. And you should see your GitHub account says that I'm logged in as myself. So having any issues, do that. And then you should be able to push to your own repository on GitHub. Once your repository is on GitHub, anybody who has access to it can then clone it to their local machine. So again, same way we have a copy of it locally and a copy of it hosted, anybody else can take that hosted copy and copy it locally. To do that, all you need to do is do this dropdown, and it'll give you a URL if you're using HTTP. There's a couple other options, but this is just the default. Copy this, and then let's say that I was somebody else in some other folder. So I will go back, make a directory, other user, and cd into it, other user. So let's say this is somebody else on their own machine and they want to contribute to my Git repository. All they need to do is git clone and paste that URL. And then you can see, if I change directory into it, git demo, that all those files are right there and they can make edits to them. Let's go ahead and simulate what it might look like to have multiple people working on the same project using GitHub. So right now I have this other user git demo, which I just cloned. I'm going to actually go back into 61D make a directory and say Aiden, and then I'm going to move, also use the move command to move folders. I'm going to move git demo into Aiden. And so then I cd Aiden, and I have my git demo, and then cd other user, and I have my git demo. So let's say I'm another user and I'm just going to go ahead and make some changes. Start, I can just push to the main branch. So I'm on the main branch, and I will just create a file. So I'll say touch file made by other user.txt. And then status, right? We created a file and we can, as we've done in the past, add it and commit it. Created another file, like so. But again, now we have multiple people working on it, so we don't want to just keep this locally. We want to push these changes up to GitHub so that other people can see them. To do that, again, we use the git push command. So we can say git push origin main. We say main because we're pushing to the main branch. So we can do that. And then if we ls, we have all these files, including file made by another user. And if we, don't worry about that, refresh, we have file made by other user.txt. But if we were to cd back into Aiden /git demo, like so, we can see we don't have that other file because we have those changes posted on the local remote, or sorry, not local, on the remote GitHub repository, but we don't have them locally. In order to sync that, in order to have those changes available locally, what we need to do is we need to pull them down from GitHub. So to do that, we say git pull origin main, like so. And then it's going to get us all those latest changes. And if we ls, we can see we have file made by other user.txt, like so. What we just showed doesn't work too well, though, when, again, you're trying to implement branches. If I was really two different people instead of just one person editing the same Git repository from two different folders, I wouldn't want to push directly to the main branch because I wouldn't know what other changes had been made, and I wouldn't want to just go directly and say, hey, this is the source of truth, without maybe having the chance for somebody else to look at it. In order to create a branch and do so with GitHub, we can follow the same process that we have done so far. We can check out to a new branch, and we'll say, we'll call it feature 3, like so. And then we can maybe just create a file. So feature 3.txt. And then if we open this in VS Code, we can edit feature 3 and say this has lots of cool things, etc. Whatever we want to do. Then we can add and commit to this branch. Created feature 3. But we don't want to then go directly to merging this into main without potentially getting a chance for somebody else to look at it. Normally, you don't do a merge locally. We wouldn't go, we wouldn't git checkout main and git merge feature 3. What you would do is you would do this through GitHub so that you have the ability to create what is called a pull request. So let's check out back to feature 3. And what we want to do is say git push origin feature 3. So we're not pushing to the main branch, we're pushing to this new feature 3 branch. So we can push like so, and then go back to GitHub. Oh, what are we doing here? GitHub, refresh. And now we have two branches. We have our main branch and our feature 3 branch, and we can view the differences, right? This one has this feature 3, and it was created using the feature 3 commit. If we want to merge this into the main branch, the standard procedure is to create a pull request, which is a request to merge code. So you add a title, say created feature 3, whatever description you want. So I'll just say added the requested feature like so, and we can create the pull request. So now we have the request to merge in this change, but since GitHub allows us to collaborate, there's lots of different things we can do here. We can label it so that we can categorize it. We can request for a reviewer. So right now it's only giving myself, but I could request a reviewer. Clear that, or yeah, like so. We'll cover that later. But what it does give you is this nice diff view. So this is basically the equivalent of if you had run git diff locally. And you can view it, see, okay, is it all good? We added it. And then eventually, if we'll say you run some tests and they all pass, you're ready to go, you can merge the pull request and confirm merge, like so. And then it is going to merge it. So that's the equivalent of if you had run git merge locally. So when you're using Git, a lot of the time, or sorry, when you're using GitHub, you don't necessarily need to git merge or git diff locally because you can push it up to GitHub and see it there. And again, right, other people can add comments, say this is good, this needs to change, etc., etc. And we're done. So now we can delete the branch and go back like so. Final thing that's important when you're hosting your Git repository is the idea that there might be certain things that you don't want to get pushed up to GitHub, especially if your Git repository is public, but even if it is private. For example, you might have what is called an environment variable, which is something like a login to your database. So obviously you want to keep that secret, make sure nobody else can access your database except your authorized server. And to achieve this, we can create what is called a gitignore file. And all it's going to do is it's going to specify files that are not going to be tracked by Git. So we can check out back to the main branch and remember that we have to pull the latest changes we just made. And then what we can do is we can create a .gitignore file. It has to specifically be .gitignore, otherwise Git won't recognize it as being a file that's specifying what you want to ignore. So what we can do is we can specify file names or folder patterns that we want to ignore. So a common thing is to have a .env file, which has secret information that are essentially like passwords, except for your application. So if we were to create that, add commit created gitignore, gitignore. So then if we were to create a .env file, it will not be tracked by Git. So we created the .env file, but if we run git status, we'll see there's nothing to commit. The working tree is clean, even though we created the env file. We can put whatever we want. So say, password equals secret, and it will not be tracked. There's a couple other things you might want to put as being ignored. You might have local build outputs or debug logs, or even just the ability for people to create like scratch files that you don't want to then get pushed. Right? But we can, here I'll even prove it to you, git push origin main, and our .env file will not be in the Git repository. So there you go. That is your introduction to the basic usage of Git and a little bit of GitHub. There is a huge number of additional features both within Git and within GitHub, but it makes sense to kind of naturally discover those as you run into them and not try and learn everything at once. The few things you did learn, just basic branches, commits, pushing, is really all you need to get started. If you want to review it, we can look at a sort of diagram. You have your working tree, which is what is locally on your device, which is different from what you stage, which is when you add it or you could restore from it. You commit to create something local, and then eventually you push it or pull from a remote repository. So now, final thing we're going to do is we're going to do what is prompting us to do and add a README file and learn about Markdown. Markdown is a simple method of styling text that doesn't require a complicated editor to add or move styles. Let's look at an example of editing something in a Google Doc. If I want to change something, so I have something that is italic, something that is bold, I have to either use the little button or toggle with my keyboard. I could, I to change italic. But it's not immediately obvious sort of how this would copy and paste over to some other program that's trying to render text. If I were to directly copy and paste this into a Discord chat, my link wouldn't carry over, and also my bold and italic text would not properly carry over. Markdown fixes this. So let's say I am editing my README Markdown file and I create a link. So to do that, I go link like so, and then I could just have a link to the 61D website. So like so, and I render it, preview this link. If I were to copy and paste this to a Discord message and send it, which I'm not going to because this is just a public server, then it would keep that same formatting of that same link. And also, right, I can add that link just with my keyboard, as you saw, right? All I had to do was add the bracket syntax. I didn't have to have a bunch of different options to say, hey, add this link or anything like that. And the reason you need to learn it specifically is that Markdown is the most common format used for developer documentation. Whether you're documenting your own repository, like we are here with a README, or you are reading or editing documentation for some other project or some other repository. For example, we can take a look at the React documentation, which you'll learn about React later. And as you can see, it's Markdown based. So they do a bunch of fancy stuff to make it look all pretty, but you have your first component. Some italic components are one of the core concepts of React. You can go to the source code and view the raw code, and you can see components. We have the same italic styling that then renders italic there, or we could render italics right here because it's a common format in which the styling is included in the syntax of the text. There's only a few basic pieces of styling you need to learn for Markdown. You have italic, which is either single asterisk or single underscore, bold, which is either double asterisk, double underscore. Headings are the number of hashtags to indicate how large of a heading. So is it a big heading is 1 hashtag, smaller heading, 2 hashtags, even smaller heading, 3 hashtags. A link has in brackets the name of the text that you want to be a hyperlink, and then the actual source of the link. An image is the same syntax, except you put an exclamation point in order to indicate that it should render as an image. Block quotes just sort of highlight some text. Bullet lists, you can either again use asterisks or dashes. Numbered lists almost look exactly the same, just number period or number parenthesis. Create horizontal line or inline or multi-line code blocks. So let's try it out with our own repository README. Almost every repository, it's standard practice to have a README file, which just gives an overall explanation of what the purpose of the repository is, how you can run it, and might link you to other relevant documentation that you might need to understand how it all works. So let's practice all those core pieces of Markdown syntax. To create a header, we might want to say the name of the repository. So say git demo, and just include some basic text to say that it is a repository for created to learn Git, exclamation point. You might want to have an image of the Git logo. So you can just copy image address and then exclamation point, brackets, Git logo, like so. And maybe we want to have a link to the Git docs. So we can do there and link to the Git docs, like so. We might want to put this under a subheading. So we could do 2 hashtags and say relevant sources. And then we could list what we learned. So say what we learned in it. We learned add, commit, and a couple other things. So if we want, we can then preview this, see what it's going to look like. Again, we have our nice big header, smaller headers, ordered list, and go from there. As you can see, right, since we have this standard format that's easily recognizable, GitHub can do things on top of it, such as give us these little header references that we could click. Oops. Ignore that. So that you can link directly to a specific heading. So again, we'll just do maybe some italics, like so, and bold for Git. Preview, italics, bold. Finally, if we want to add a code block, you do 3 backticks, and you want to include the name of the programming language so that it can be properly highlighted. If we wanted to have a bash script, we could say that we can git init, and then maybe git add and git commit, initial commit, like so. And we will get nice syntax highlighting because it is the correct programming language. So we can go ahead, commit those directly to the main branch. And now it'll automatically display our README underneath our Git repository, like so. So there you have it, Today, we covered Bash and command line interfaces, including the basic structure of a command line interface and a lot of different Bash commands. We talked about both Git and GitHub, all the various different actions you can run through, and finally talked about Markdown. As you can see right now, there are notes that accompany this video, this lecture, located on the 61D website, which will be linked down below. We have them for Bash, Markdown, and both Git and GitHub. And over time, we will update them. They also include some nice things that we didn't cover, such as creating network requests with a Bash script. Also, if you want to practice what you learned today, we have an assignment which goes along with this lecture. It runs you through completing exercises that are similar to what we covered during the lecture. One final thing is you may not have your GitHub interface look exactly like mine. That is because I have two Chrome extensions installed. One being material icons for GitHub, which gives you these nice icons, and another being redefined GitHub, which adds a bunch of additional features on top. All that and more will be linked below. Now that we have those essential developer skills out of the way and you are complete masters at them, or will be soon one day, you are ready to move on to some actual programming in the next lecture, which is written as lecture 1. We will be covering JavaScript. Till then, have a great day.